Okay, so we've been talking about exoplanets and calculating things like the mass of the stars that they orbit around. In this particular video, we're going to consider the acceleration due to gravity on the surface of some of these what are called terrestrial exoplanets. Terrestrial exoplanets are those that are most Earth-like, and when Kepler 10b was initially discovered, astronomers and astrophysicists thought that it might have some characteristics of Earth. As it turns out, it is a rocky planet. However, it's too close to its star to be able to support life as we know it. The star has a massive solar wind, which has driven away any atmosphere that Kepler 10b might have, and also just inundates the planet with solar radiation. So it's not a very hospitable place. Now, in the previous video, we calculated that the acceleration due to gravity on Kepler 10b is 16.9 meters per second squared, and that's an approximation, of course. Okay, so if you were a person who had a mass of 75 kilograms, and we wanted to calculate your weight, we would multiply your mass times your acceleration due to gravity. And since your mass is 75 kilograms, we multiply that by 16.9 meters per second squared. And when we multiply those two, let's do it here on the calculator. Okay, let me move this over a bit. We would have 75 times 16.9, and we get that answer that's displayed, which is at 1,267.5 newtons. Now, the measure of weight that you're most commonly knowledgeable of is probably, at least here in the United States, we measure our weight in pounds. And so the conversion factor between newtons and pounds is that 1 newton is the same thing as 0.22481 pounds. So let's take that number of newtons and multiply it by 0.22481 to see what your weight in pounds would be on the surface of Kepler 10b. So we multiply by 0.22481, and the result that we get is 284.95 approximately pounds. So that would be your mass, or rather, not your mass, your weight on the surface of Kepler 10b. You would weigh 284.95 pounds. Now let's compare that to what you weigh here on Earth. Now, here on Earth, the acceleration due to gravity is 9.81 meters per second squared. And again, to calculate weight, we multiply mass times acceleration due to gravity. So we would do 75 times 9.81, and we get 735.75 newtons. Now, again, that's newtons, your weight in newtons, which is correct, because that's the measure of force in the metric system, but we want to convert that to your weight here on Earth. So we're going to multiply that number by, again, the Newton to pounds conversion factor, which is 0.22481, and we get 165.4 pounds. So if you have a mass of 75 kilograms on Earth, here you weigh about 165 pounds. And compare that to your weight on Kepler 10b. Your weight there would be 284.95 pounds, almost 285 pounds. So that's 120 pounds heavier than you would weigh here on Earth. Right? That's because of the fact that Kepler 10b is larger and more massive than the Earth. Now let's do a similar calculation for Kepler 10c. For Kepler 10c, the acceleration due to gravity is 13.09 meters per second squared. So we're going to calculate the weight in newtons, and we would do 75 times 13.09, and we get 981.75 newtons as the weight on Kepler 10c. Now, again, that's in newtons, and we're going to convert that into pounds, and we do that by multiplying by the newtons to pounds conversion, which is 0.22481. and we get 220.7 pounds. So again, just to compare, your weight here on Earth, if you have a mass of 75 kilograms, your weight here on Earth in pounds would be 165.4 pounds. Your weight on Kepler 10b would be 284.95 pounds, and your weight on Kepler 10c would be 220.7 pounds. So there are some interesting effects that gravity has, right? Both of those planets, Kepler 10b and Kepler 10c, are larger and more massive than the Earth. So you can see why there would be a larger weight if you were to be standing on the surfaces of those two planets.